this earlier, that this problem is similar to the previous problem we have in terms of the percentage to the left. Now they changing the wording for you guys, or they changing the item, not the item, but the wording, right? Last time they tell you that we have 0.25 to the left or 25% to the left of the item or to the right. But now what if they ask you this thing here and they say the mean, which we mentioned, we need to know the mean and we need to know the standard deviation. So the normal population have the mean of 67 and the standard deviation of 4. What is the 45 percentile of the data? So this is the new thing that they have, or the new thing that you see, that is a 45 percentile. Reminder in chapter 3, the percentile is basically tell you that you have your data and you split your data into 99 slices, right? Meaning 100%, but you cut into 99 slices, and each slide is 1 percentile, right? 1 tile. So in the sense, this 45 percentile is the same concept as tell you to find the data or find the percentage from the left to that given value that represent the 45 percentile, which the word percentile is basically the same idea that tell you that the 45 percentile is the 45% to the left of the data. In this case, the percentile is basically tell you that is 0.45 to the left of your data. So we know that now it's just changing the word, but if we know the item on the left, and to go back to your calculator, for those of you who wasn't here last time, to go back to your calculator again, to do this calculator, this is what you need to do, is you need to hit second var, V-A-R-S, second var, and like I mentioned, we only use the normal CDF and the inverse norm. And because they give us the area, the percentile in this case, which is the area to the left, all we need to do is go to the inverse norm. And for your TI-83 user, you have to type in 0.45 manually, comma, the mean, which is 67, comma, the standard deviation, which is 4, and close your parenthesis. For your TI-84, you have that prompt. For your TI-83, you have to manually type in the first value, which is the area to the left of your data. The second value is your mean, and the third value is your standard deviation. So if you type this thing in, this is what you have, is 66.497 or 66.5. And again, that's basically tell you that if you score, if this were to be, again, on part C, they say that this is test 1, the result of test 1. If you score 66.5 on this test, you will be at the 45 percentile, meaning you are better than 44 other people, okay? So that's the idea. It's not new. It's the same as we did on Tuesday. It's just that now the wording, instead of tell you that 45% to the left or the item to the left, now they put in the wording percentile. And you need to correlate that percentile is the same as the area or the percentage to the left of the value. And if we can correlate that, we can find the value itself. And same idea for B, they ask you the same item, they give you the same mean and the same standard deviation, but now they ask you what is the 92nd percentile, right? 92nd percentile, in this case, we know that the percentile tell us that is the percentage to the left. And in this item, the percentage to the left will be 0.92, right? Convert to decimal, because your calculator can only use decimal. Do not put 92 as in the percentage. So 0.92, which is your decimal correlation of the percent. And if you put in your inverse norm 0.42 comma 67 comma 4, you will get 72.62. Meaning if you score 72.62 point on your test, you will be the 92nd percentile. you are better than 91 other people, your position is the 92nd. Okay, basically the position from the left is the 1, the 2, 3 up to the 92nd percentile. So in another word, percentile is just the area or the percentage to the left of your data. Question here with A or B, again, hopefully the word in percentile does not confuse you in terms of the material itself. So question, and any question with your calculator, anybody does not get this number on your calculator? All right. If you don't have a question, let's take a look at C. And they say the given the data in part A is the result of test 1. At what grade will we consider to be a top 7%? So the top 7%, what does it mean, top 7%? Do you agree that anything on the right of this number? So this is what they ask you is, what score should you make to be considered a top 7%? And in order to be a top 7%, again, our small data is from our lower percentage on the left, is keep on going all the way to 100%. So the top 7%, which is, this is my top 7% because the lower percent to the left and the upper percent to the right. So in this case, the top 7% is the area to the right, or the percentage to the right. And if we have the percentage to the right, and my calculator cannot calculate the percentage to the right, right? So my calculator cannot calculate the percentage to the right. Reminder, we need to do that small manipulation. We need to alter this item a little bit. And I need to take this item on the right minus from 1. The reason is the total percentage is 100%. Therefore, it's 1 take away. If I take away the right side, I will end up with the left side. And the only reason why I do this is because my calculator can only calculate on the left-hand side, right? And if I calculate this thing here, as you can see, if I manipulate and I see that it's 93% on the left, so I change it to 0.93, the mean and the standard deviation is the same. And if I type this thing in, I should have 72.903, meaning if you score 72.903, you will consider to be a top 7%. If you score 73, you are in that 7% region, right? If you score 90, you are in that top 7%. Okay. So again, this is the idea. They give you this small concept. They give you the small concept that if they ask you for probability, ask you for the area, ask you for proportion, you use the normal CDF. If they give you the area, give you the percentage, or in this case now, if they give you the percentile, you use the inverse norm. It's just that now we kind of adapt to our problem. And again, just because my calculator is limited, they can only find the area to the left, I have to take that away from 1. Okay, so question with this slide, A, B, or C? If you don't have questions, similarly, let's put all of this thing into real life situation, right? This is basically probably typically your problem, right? So they say that the report on this site stated the weight of this boiler, the chicken, right, is approximately normally distributed. Again, they only give you normally distributed because we want to have that bell-shaped curve. So they are normally distributed with the mean of 1,387 gram and the standard deviation of 161 gram. Now, A, they actually find the 93rd percentile of the weight. And hopefully you guys see that 93rd percentile is very similar to previous problem C we have, right? 93rd percentile, the percentile is basically tell you that it's the percentage to the left. And in this case, 93rd percentile is 0.93. And the only thing changing from this problem to the previous problem is your mean is different and your standard deviation is different, because in this case, this is the weight of the chicken. On the last time is the score on the test. So the number is different. So in this case, we have 0.93 comma 1,387, comma 161. And if you type this thing in, do you agree that the chicken weight 1,624.6 gram, if they weigh this much, they will consider a 93 percentile, meaning they are weigh more than 92 other chickens, okay? If we have 100 chicken in this form, okay? So again, this is the idea is, we're using that same concept. It's just that the problem, they changing the wording for you or on you, right? For B, they say find the first quartile of the weight. So what is the quartile? Unlike percentile, quartile, we only divide the item into 4 regions or 3 slices, right? So again, quartile is basically the quarter, right? The first quarter, the second quarter, the third quarter, the fourth quarter, right? So in this case, the quartile is basically tell you, to correlate back is basically tell you the 25 percentile, the first 25%, right? So the quartile is the first 25% in the same of this item, which is 0.25 because it's 25%. And if I know or I can correlate that that is the 0.25 on the left, I can use my inverse norm and put this thing in as what we have here, right? So looking at this item, the chicken weight 1,278.41 will be considered as in the first quartile, meaning this is the maximum weight that in the first quarter, right? Anything below this is in that first 25%. Anything more than this is will be in the last 75%, okay? So question with A or B, or how to start with A or B here. Right. If you don't have question with A or B, let's take a look at C. And probably C is a little bit confusing for some of you guys, but let's take a look at this thing here. A chicken farmer wants to provide a money back guarantee that his broiler will weigh at least a certain amount. What way should he guarantee so that he will only have to give the money back to only 1% of the time? So this is, his advertiser, like he wants to put an advertise in terms that if you come to my farm and you buy this chicken, if it's less than this certain weight, I will give you your money back guarantee, no question asked, right? So what will be that minimum weight that he wants to have, right? So do you agree that the 1%, he only wants to give back 1%, meaning as long as the chicken weight less than this certain weight, whatever this weight is, as long as it's weight less than this thing here, he will have to give the money back. Meaning this 1% is the 1% on the left-hand side, because if any chicken weight more than this, well, you pay for it, right? If any chicken weight less than this, now that's my mistake. I will give you your money back, right? So again, looking at this thing here, I sketched this item just to show you that the 1% is on the right. And this is not really 1%. 1% is something very small down here. I just give you the room so that you can see that we shaded to the left. And this 1% that he guaranteed to give it back, if the chicken weigh less than this weight, that's where he gives the money back. And that's why, the further on the right, the bigger the weight, the heavier the weight, right? As you can see, A and B, this right here, 1,600, and down here is only 1,200, right? So look at this item. If we know that the area to the left is 1%, in this case, 0.01, which is correlate to the decimal place, do we know, or do you agree that this is all we need to do is just plug in the inverse norm so that you can find the weight of your chicken, or the data in this case? And if you plug in inverse norm 0.01, the mean is 1387, and the standard deviation is 1.161. You can see that this is a minimum weight of the chicken that he will give you the money back, right? So if the chicken weigh less than, he would say, if the chicken weigh less than 1,012.46 gram, I will give you the money back, right? If any chicken weigh more than this weight, it's your chicken, you bought it, right? So that's the idea here is they give you this scenario and you have to decipher what percentage do they give us, right? If he changing this thing here and he say that if they change the question, they say he want to know what is the top 1% of his chicken, right? What is the minimum weight for a top 1% of his chicken? Well, if it's a top 1%, will be the 1% on the right hand side, right? The top meaning the superior chicken, right? So the chicken on the right hand side or the percent on the right hand side will be the top. In this case, he want to minimize his refund, so the 1% is on the left hand side. Question here. And if you don't have question, we did this last time. We did this last time. Let me go over this one more time so that you guys can see if you guys struggle this from yesterday or from last time. And then when you do the homework, hopefully you can see it a little bit clearer, right? So one thing is, this survey is they ask the college student how much hour do they spend on the week before final exam, and the result come back, and this is what they have is the mean on average they will spend 25 hours, and the standard deviation is 7 hours of study the week before, right? And then on A and B, we just gonna do A and B, and they ask you what is the probability of a random. And again, hopefully you guys can see that, hey, what are they asking me? Because they asked me the probability, because they asked me for probability, that is the word that trigger that you have to use the normal Cdf, because the probability, a proportion, and the area, if they ask you that, what is the proportion, what is the area, what is the probability, that is what we're looking for, is the area underneath the curve. And to looking for the area underneath the curve, we need to use the normal Cdf. Okay, and if you look for B, if you see that they give you the percentage. If they give you the percentage, we are doing the normal inverse norm. Sorry, the inverse norm. If they give you the percentage, right? So look at A, and just as I hope that you do this practice, that all of this problem 6.1, 6.2, 6.3, sketch your normal curve, right? Looking at this item, this is what we have. They give us the mean, they give us the standard deviation, and they ask us what is the probability of the random selected student is between 15 and 30, which is, this is the area we're looking for, is between 15 and 30. And if we look at this area, hopefully you guys see that the reason why you sketch this, and we know that we use the normal Cdf, the reason why you sketch this is to show you what is your left endpoint and what is your right endpoint. And in this case, my left endpoint will be 15, my right endpoint will be 30, and the mean will be 25, and the standard deviation will be 7. If I plug it in, you will get 0.6859, meaning roughly 68.6% of the student spend between 15 hours and 30 hours of studying the week before the final exam. Okay, so that is the idea in terms of this problem. Is if you look at this problem, they can ask you both items. How do we determine when do we use the normal Cdf versus when do we use the inverse norm? Okay, and if you look at B, this is what I mentioned last time, is the only thing different in this problem is they did not give you the middle. They did not give you the left hand side. They not give you the right hand side. They give you the middle percentage, right? Last time they give you the percentile, which is the left area. They give you the top 7%, which is the right area, or the 1%, the minimum 1% that refund, right? But now they changing the word and they say middle 80%. So you have to identify or to recognize that this is the middle 80%, right? This right here, if you sketch the graph, this is my middle 80%. And we went over this last time because they tell us that the middle 80%, I have to take the total probability, the total percentage minus what they give me, which in this case, if I minus this thing here, 100 minus 80%, I have 20%. And the 20%, you can see that the 20% is not just the 20% on the left of the 80 or the 20% on the right of the 80. Because the 80 is in the middle, I have two-sided. I have the left side and I have the right side. And to be fair and because of this thing is symmetrical, because this thing is symmetric, all we do is, because they are symmetric, we need to take this 20% and divide it by 2. Why? Because we have two-sided. We have the left side and we have the right side. So if I divide it by 2, they came out to be evenly in terms that the 10% would be on the left side and the 10% would be on the right side. Because I know 10% and 10%, that's 20%, and 20% plus the middle 80%, plus the middle 80%, that will give me the total of 100%. So that is the reason why I need to divide it by 2, because I have two sides. They give me the middle. They did not give me, if they say the left is 80%, then that's the left side, right? Then the right side would be 20. If they say the right side is 80, then we know the left side is 20. It's just that now they change it up and they say the middle. And if it's the middle, we need to divide the leftover by 2 because we have two-sided. And if we have this, then all we need to do is, now I need to find this 2 value, right? They ask me what are the 2 value, and because I'm looking for the value, I need to do an inverse norm. And my inverse norm, I need to know the area to the left of the first value, and the area to the left of the first value will be 10%. And all I need to do is put in inverse norm 0.1, comma, the mean, which is 25, and the standard deviation, which is 6. And if I do that, this is what I have, which is the hour that the students study is between 16.03 hours. And now to find the right-hand side, to find the right endpoint, to know the area to the left, I need to take the 10 plus the 80, right? To find this area, and my calculator can only calculate the area to the left. So I need to take 10 plus the 80, and that's where my 0.90 came from. And 0.90, and I put in this item, and my answer, or the 2 value, will be between 16.03 and 33.92. And again, this is what you have. And some of you guys sent me a email about this question, and this is what we did in the sense that if they give you the middle portion, only when they give you the middle portion, you need to divide by 2 because there are 2 tails. You will hear me say a lot of tails in chapter 7 and chapter 8. But for now, because there are 2 regions on the left and on the right, and that's why we divide by 2. You know, and same idea with C. We did this last time. Because the middle is 76, we know that 100 minus 76 is 24. Divide that by 2, we have the 2 tail, which is the 12%. And again, the other one, the 12 plus the 76 will give you the 0.88. And your mean and your standard deviation is the same. So look at this thing here. Question with this material, when do we use the normal CDF versus when do we use the inverse norm? And how do you use the normal CDF and how do you use the inverse norm? Any question here, ladies and gentlemen? Right. If you don't have question, again, this is the last item we have, which just tell you when to use your normal CDF versus when to use your inverse norm. So if you don't have question with 6.1, let's take a look at 6.2. So 6.2, as I mentioned to you guys earlier, 6.2 is just similar or just exactly the same as 6.1. The only thing, and the main thing I should say, is we are not dealing with the population data. In 6.2, we are dealing with a sample data. And in realistically, right, in real situation, we probably won't have the population data, right? We don't have the whole entirety of the item for our disposal. We have to use the past record, and then we have a sample of each of the record, right? So in the sense of this thing here, this is what the idea behind 6.2 is. If we have the sample, and each of this sample, if you take out each of this sample and you calculate the mean of each of the sample, and you will see that if you draw the sample out and you take the mean of each of the sample, eventually this sample mean is equal to your population mean. Okay, so this is what we have is sampling distribution. Is basically we take each of the small sample from a group of population, and then we find the average of each of that group of sample. Okay, so our goal is, well, if we have this item, they show us, or this come out to be a central limit theorem. So the central limit theorem is just basically tell you that if you were to take the sample size of your data, of your population, and if you take this sample size, a lot of the sample size, right, increase with our limit, meaning if you take this n more and more and more and more, if you take it a lot of time, then this eventually become the population. It's become a normally distributed. It's just like it's the same concept as if you flip the coin, right? If you flip the coin, if you flip more and more and more, it's eventually come out to be 50-50. Okay, so this is basically the central limit theorem. It just tell you that if you take the n, if you take a lot of this item, they will eventually become a normally distributed item. But because of that, because we are dealing with a sample, and this is the only thing that you need to do, ladies and gentlemen, is you remember I told you guys that we need two things to find our normal CDF versus the inverse norm. We need the two things, which is we need the mean and we need the standard deviation. So the only thing to be in short is whenever you deal with a sample, you have to alter your standard deviation. We cannot use the population standard deviation when we deal with a sample standard deviation. So to alter this standard deviation, we need to take the population standard deviation divided by a square root of n. And the n is just the number of sample you have. Okay, so in the short, like I mentioned, is if you collect a lot of data, we know that this become a normally distributed item. But how large is large, right? How large is this sample have to be? Because based for our practice, we will use 30 as our base. If the n is bigger than 30, if the n is bigger than 30, we say that is enough. That is good enough for me. If the n is 30, we can use it. We will say that the population will be normally distributed, and we can process or proceed like we did in 6.1. The only thing is we need to change the standard deviation to become a sample standard deviation, or in terms of take a population divide by a square root of n. Okay. The other thing is if you don't have the n to be bigger than 30, if you cannot find the n bigger than 30, the other idea is if your population is normal, then we still can use it. Okay, so if your n is not bigger than 30, then your population have to be normal. We have to know that our population is a bell-shaped curve for us to do it regardless of how many sample we needed. Okay, so if we know the population is normal, the n can be 2, n can be 7, we don't care, we can do it because the data itself is bell-shaped curve. If we don't know that the population is normal, then you have to have at least 30, well, more than 30, so at least 31. Okay, so again, those are the two criteria for you to using this method or to using this central limit theorem. for us to use the normal distribution for the sample, that's the two things we need. We need the sample size to be bigger than 30, or we need the population to be normal itself. If the population is normal, the sample size have to be bigger than 30. If the sample size is not bigger than 30 and the population is not normal, we cannot use it. Okay, so those are the two criteria we have. And the other thing that we have is the sample standard deviation, or sometimes you will hear me say, or not, sometime later on you hear me say that this is your standard error of the mean. Okay, so the standard error is just another word, just a new word. Standard error is basically tell you take the population standard deviation, divide by a square root of n. Okay, so looking at this thing here, before we do the calculation, and when we get to the calculation, you will see that is very identical to 6.1. But before we do that calculation, let's take a look at this item to see when can we use it, when can we use the normally distributed bell-shaped curve 6.1 to apply to the problem. So let's take a look at this example 1. A sample size of 15 will be drawn from the population with the mean of 125 and the standard deviation of 28. Is this appropriate to use the normal distribution to find the probability of X, the probability of whatever this thing is? So looking at this thing here, is this appropriate to use it? Hopefully you guys say, no, Mr. Tran. You just told me that the sample size have to be bigger than 30, right? So in this case, everybody see that the sample size is only 15, which is smaller than 30. My cutoff is got to be 31 or more, right? So bigger than 30 in this case is not bigger than 30. So if it's not bigger than 30, we cannot use this item. So in this case, this is what we have. We say no. Why? Because the sample size is not bigger than 30. Okay. Is this appropriate to find the probability of X less than this? Same thing go. We cannot, because the sample size is not bigger than 30. And again, same thing go, is it appropriate to find the 90th percentile, which is the inverse norm? Same thing go. We cannot do it because the minimum sample size that we have have to be bigger than 30. Okay. So again, this one here, you say, wait, Mr. Tran, so what do we do if we cannot do it? Well, this thing here, they just ask you, can you do it or not, right? So in this case, we cannot do it. We cannot because it does not fit the criteria. The criteria that have to fit is they have to be bigger than 30. Okay. So looking at this thing here, 2, they say that sample size of 5 will be drawn from a normal population with the mean of 60 and the standard deviation of 12. Is this appropriate to use the normal distribution to find the probability of this item? And you will see that the answer is yes. And you will say, wait a minute, Mr. Tran. On the above problem, you say that the sample size have to be bigger than 30. And yes, the sample size have to be bigger than 30. So what is the difference between this problem versus the previous above item? This is the biggest item, or this is the biggest. It's a small word, but this is what we need. Remember, we have 2 criteria. The 2 criteria is if the population, if we know that the population is normal, meaning your population is a bell-shaped curve. If we know that the population is normal, then doesn't matter what the sample size you have, like I mentioned earlier, right? The sample size can be 1,000, can be 3, can be whatever. If your population is a bell-shaped curve, then whatever the sample size is still a bell-shaped curve. Up here, they did not mention anything about the population. They just say that I have this population and I took out 15 of them. And because I don't know what population, what kind of population this is, this population can be skewed to the left, can be skewed to the right, can be a reverse bell-shaped curve, can be anything I don't know. And they did not tell me, right? And that's your challenge, ladies and gentlemen, is if you see this normal population, then doesn't matter what the sample size is, we can still use it. We can use 6.1 to find this item here. this item here, because the sample size, because the population is unknown, well, it's not unknown, right? Well, we don't know what kind of population this is, so we have to have a big sample size. We have to have 31 or more. Okay, so everybody see the difference between the top example versus the number 2 here. So once you identify that we can use it, now let's take a look at how to use it, right? So the first one is, when can we use it? Now, once we know how to use it or know when to use it, how do we use it? B, they ask you, is it appropriate to find the X bar, which is the sample mean, find the probability that the sample mean will be between 50 and 70. So if you look at this item here, looking at this thing here, the first thing we need to do is, again, sketch your item. I will go back to that. Sketch your item, right? They ask you this, which is similar to 6.1. Is it appropriate to find the probability that the sample mean will be between 50 and 70? So we're looking for the probability, which is we're looking for the area underneath the curve. And to looking for the area underneath the curve, we know that we will use the normal Cdf. And this will give me that the lower endpoint will be 50, the upper endpoint will be 70, which is the lower limit and the upper limit. We're looking for the area here, right? And if you remember, in order for you to use the normal CDF, we need to have the mean and we have to have the standard deviation. So in this problem, in this section, 6.2, because we deal with a sample standard deviation, or because we deal with a sample item, this is what you need to have, is we need to have a sample mean. And ideally, the sample mean is the same as the population mean. So it doesn't matter which mean they give you, it's the same mean that we will use it. And now this is where the main difference of 6.1 and 6.2. If in 6.1, we will use 12 as your standard deviation. In 6.2, because we deal with a sample, we have to alter our standard deviation and to find the standard error, or in this case, the sample standard deviation. And based on this sample, we need to take the standard deviation and divide it by a square root of n, which is a square root of the sample size, okay? So once you identify this is all you need to do, is type in your normal CDF, your lower limit, your upper limit, your mean, and your standard deviation. And if you were to do this, ladies and gentlemen, if you were to do this, you can type it this way. You can type the way that you see it on the screen. So if you were to type the way you see it, which is second VAR, normal CDF, and again, looking at this item, all we do is we have 50, comma, 70 as the upper limit, comma, the mean is 60, comma. Again, if you want to type the way that you see, you have to put in parenthesis 12 divided by second square, which is your square root notation is right here. Your square root notation is this item. And then you put in 5, you just close your parenthesis. And then you just, if you want to type it this way, you can type it this way in the cent to give you 0.96759. One thing is, if you don't want to type it this way and you want to use the decimal place, and again, if you do the decimal place, reminder to use as many decimal place as you can. So if you take a look at this thing here, and I want you, or you should use at least 6 decimal place. Do not use just 5.4. Don't round your standard deviation, because let's say that you divide this and this is what you have. And if you were to type in that item that you just type in, normal CDF, 50 is my lower limit, 70 is my upper limit, my mean is 60, and my standard deviation, let's say 5.4. If you're using the 5.4, you say, oh, I don't want to type the 12 divided by square root of 5. I just want to use the decimal. If you just type in 5.4, everybody see that the answer is different from what our previous answer is. Our previous answer is 0.93759. This thing here is 0.93595. Meaning, again, is a little bit smaller. The reason is you make your standard deviation bigger. So that's why your answer would be smaller in that sense. So if you remember in chapter 4 and chapter 5, I told you that in the process, you don't want to round up your item in the process. You only round your answer at the last final step. So if you want to use this standard, not that you want to use, but you have to use the standard deviation, and you want to use the decimal place, you want to type as much decimal place as you can, which in this case, 6 number is fine. If you use an 50, 70, 60, 5.3666563. If you're using this thing here, you will see that it's very close to our original item, which is not 0.9375759, right? So that's what we have. So if you're using your calculator, and most of this thing here is calculator dependent, make sure that when you use your decimal, make sure that you use more than 5 decimal place. To be safe, more than 5 decimal place. Don't use 5.37. If you use that, it will be a little bit off, okay? So you can either type it this way, which is 12 divided by a square root of 5, or you can use the decimal, but when you use the decimal, if you use the decimal, make sure to use at least 6 decimal place after the decimal to be safe, okay? But the idea to go back, the idea of chapter 6.2 is the same as the prior 6.1. The only difference, the main difference, and this is your object to decipher your problem, is when you deal with a sample, you have to convert your standard deviation to become a standard error. And that is the only thing that we have is different from 6.1. Is your standard deviation no longer the population standard deviation? We have to use the standard error, okay? And again, let's take a look at C, and then C, 85 percentile. And percentile tell us that this is the percentage to the left, and the percentage to the left, we know that we need to use the inverse norm, and the inverse norm in this case will be 0.85, comma, the mean, which is 60, and the standard deviation, because we deal with a sample, we have to use the standard error, which is square root 12 divided by square root of 5. And if you do this thing here, meaning, again, based on this, whatever this data is, this can be the test, can be whatever. If you score, let's say test, make it easy. If you score 65.656, you will be at the 85 percentile, right? So looking at this thing here, the calculation, hopefully you guys see that the calculation, the feature that you use in your calculator is the same feature and the same item as in 6.1. The only thing different is you need to manipulate, or you need to alter your standard deviation to correlate with the sample. And to alter that, we need to take the standard deviation divided by a square root of the sample so that we can find the standard error. Okay, so question here with A, B, or C. Well, A is we just say yes or no if we can use it or not. B and C, question would B or C. Well, let's take a look at another problem. And if you have a question and you don't know how to ask, hopefully, let's see this question and see if you can know a little bit clear. So first of all, this is my advice to you guys, or this is what you guys need to looking for when you read this problem, right? A sample. When you see that a sample, when you see anything deal with a sample, when you see the sample, you have to know that, oh, we are working with a sample here. And if we're working with a sample, we cannot use the population standard deviation. we have to find the standard error, which is we have to alter that. So whenever we deal with a sample, that is what we have to do, is we need to find the alternate standard deviation. So we know that this is the sample that we need to draw, a sample size of 126. So we know that this thing here is big enough, right? It's bigger than 30. We're good to go. I don't care what the population is. And in this case, I don't know what the population is, right? The population can be normal, can be whatever that it want to be. I don't care. I have enough sample, right? I have more than 30. I'm good to go. I have green light. It's tell me that go ahead. You can use your approximation normal to do this item, right? So they ask you find the probability that the mean sample, X bar is your mean sample, will be between 25 and 27. So first of all, do we agree, or do you guys agree that this is what we have? Is we know that the mu is 26 because it's the same mean as we have before. We know that the standard deviation, we need to change it. We need to convert this to become a standard error, which is we need to take 3 divided by a square root of the sample size, square root of 126. And if we divide this thing here, use as many decimal places as you can. Don't use 2.67 or don't use 2.7. Okay, so those are the two things we need. We need the mean and we need the standard deviation. We know the next thing is we know that they ask us for probability. We're looking for the normal CDF. So in this case, if I sketch this item out, we know that we're looking for the probability between 25 and 27. So I know that my 25 is my lower limit. My 27 is my upper limit because those are the limit I have. And the mean is 26. And the standard deviation, in this case, the standard error, because we deal with a sample, is 3 divided by square root of 126. Or you can use 0.267261254. And again, if you type that thing in, you will get 0.9998. And again, I just put 4 decimal places to show you that the probability is not equal to 1. So again, depend on your homework, your quiz, your test, they tell you how many decimal they want it to be. So this is what we have in this item. And similarly to A, B, they give you the percentile. And because they give you the percentile, just like chapter 6.1, the percentile, which is the percentage to the left of the value, and they ask you find the percentile of the X bar, which is the value. And to find this X bar, we need to put an inverse norm because they give us the percentage, or in this case, percentile. And again, this is what I have, 0.55, comma, the mean, and comma, the standard error, which is the new standard deviation or the sample standard deviation here. And once we have this thing here, this is what we have is 26.03. So if you score, or whatever this data is, can be the weight, 26.03, you are at the 55 percentile. And again, 26.03 is a little bit bigger than 26. That's why it's more than 50%, right? So looking at this item here, let me ask you guys, let me pause and ask you guys a question, how to determine what kind of problem we have and when to use it. A question with your calculator. Go ahead.
If the sample size is 30, you can't use it.
You cannot use it. Unless they tell you that the population is normal. So it has to be 31 or more, right? Unless they tell you that the population is normal. If they say the sample size of 30 will be drawn from a normal population, then we can use it. But if it's less than 30 or 30 and below, we cannot use it if we don't know what the population is.
And what's the notation, like the mu and the X bar, and then the sample
the X bar is your sample.
X bar.
This thing is just basically tell you that the sample mean is the same as the population mean. The mu is your population mean. So the sample mean is the same as the population mean. This thing here tell you that sample standard deviation, or not really sample standard deviation, because the sample standard deviation is the S. This thing is just basically is the standard error, I should say.
Okay.
Sigma with the X bar here is the standard error. And to find this item is this thing here. So basically your standard deviation is 3. That's your population standard deviation, and your N is the sample size. So the standard error is this notation. And to find this notation, you need to take 3 divided by square root of 126. Okay.
Okay, thank you.
And if you take a look at this problem here, same idea go, right? This is what you have. You saw that this is, we deal with a sample. And if we deal with a sample, it's not 6.1. We deal with a sample, meaning we are working with 6.2. And if we work with 6.2, we need to have a sample size of bigger than 30. And in this case, we have a green light. The sample size is 284. We are good to go. Now, we need to know that in order for us to do the probability or percentile, we need to know the mean, and the mean for the sample is the same as the population. So in this case, whatever your population mean is the same as your sample mean. The only item that we need to convert in 6.2 is we need to convert this standard deviation to become a standard error. And to do that, we need to take the population standard deviation, in this case 7, divide by a square root of 284. So that's the idea, is in order for you to use, or in order for you to do anything related to a sample, you need to find the standard error. And to find the standard error, based on your central limit theorem, to find your standard error, you need to take 7 divided by a square root of the n. Okay, so those are your alternative, not alternative, but those are your pre-item to do, right? Now we know that we're looking for the probability that is greater than 46. Well, what does it mean greater than 46? Like I mentioned, sketch your normal distribution curve, right? So this is what we have, is we looking for the area greater than the 46, meaning, again, do you agree that the lower limit will be 46 and the upper limit will be some humongous number, right? In this case, I put 10 million. So looking at this thing here, again, the difference between A on number 2 versus A on up here is this item, because they ask us in between, they give us the lower limit and they give us the upper limit. This one here, because they ask us for greater than 46, we don't have the upper limit. My upper limit is some positive infinity. My calculator cannot do that, so I put in some humongous number, which is positive 10 million, right? My mu is the same 45. My standard deviation is the new standard error. And this is what we have, is the same idea as 6.1. It's just that now we need to calculate the standard error before we can plug into our calculator. And our answer is 0.008. And similarly for B, right, the percentile is the same, which is the percentage to the left. And percentage to the left, we need to use the inverse norm, and 0.75 comma my mean and my standard deviation. This is what we have, is 45.228. Okay, so looking at this thing here, again, there's no new calculation, right? There's no new feature from your calculator. And you will see in 6.4, when we do 6.4, it's the same normal CDF and the same inverse norm, okay? But the only thing new is we need to kind of alter our standard deviation so that we can deal with a sample. We cannot use the population if we only have a sample of something, okay? So let's take a look at this problem. Let's say that, you know, this is probably your typical homework question, your typical quiz question, or if I were to give you the test on paper, this is probably the test question I would give you, right? So let's take a look at this thing here, and I kind of put everything together here. So they say that the College Board report that in in a recent years, the mean math SAT score was 514, and the standard deviation was 118. A sample size of 65 are chosen. So if you see this plot, right, if you see this statement, a sample size of 65, so looking at this thing here, we know that we work with a sample. And in order to work with a sample, we know that we need to have a sample size of bigger than 30. In this case, my sample size is 65. We are good to go, right? And if you read this problem, this is what you know. If you read this problem, this is tell you that you will work with a sample, because what do they ask you? They ask you find the probability, right? Find the probability. The probability tell us that we use the normal CDF, but probability of the sample mean. The other one, they just say find the probability of the mean or find the probability of the population. So if they tell you find the probability of the sample mean, we know that we have to deal with something with the sample. And to do something with the sample, we have to find the standard error, which is we have to kind of manipulate our standard deviation. We cannot use the 118. Okay, and I see that's what you guys need to looking for. For instance, if they were to take this thing out, if they were to take this item out, if they were to eliminate this sentence, eliminate this item here, if they were to eliminate this item, then we are back to 6.1, ladies and gentlemen. If they were to take all of this, anything that relate to the word sample out, if they just say that the college recent years have the mean score of 514 and standard deviation of 118, what is the probability that the score is less than 500? Well, if they ask you that, then that is your 6.1 problem, right? You do the normal CDF, the less than, which is negative a million, 500, your standard, your mean, which is 514, and your standard deviation is 118. Okay, the difference between this problem and 6.1 is in this problem, we all work with a sample. And because we work with a sample, we need to alter this item here. So we know that we need the sample mean, or we know that we need the mean, the average, which is the sample mean is the same as the population mean, 514. And we know that we need to find the standard deviation. And in this case, or standard error, I should say, sorry. Standard error, in this case, we need to take the 118 divided by a square root of 65, because that is your sample, right? So that's the only thing new in 6.2 is you have to deal with sample. And when you deal with sample, you have to find the standard error. Once you identify that, everything else is the same, right? We're looking for some score, the mean score, the sample mean score less than 500. So we're looking for the error to the left of 500. And if we know that the area to the left of 500, this thing here show me or tell me that my left endpoint, because this thing is to the left, my left endpoint would be some negative humongous number. My calculator cannot put a negative infinity, so I put negative 10,000. In this case, I put negative, a million is fine. So negative a million, which is my lower endpoint, my upper endpoint would be 500. My mu will be 514, and my standard deviation, which is the standard error, because we're dealing with a sample. And once you plug this into your calculator, which is the same item we did in 6.1, this is what you have, which is the area underneath this, or the probability that the sample mean is less than 500 is 0.1694, or roughly 17% of the sample will score less than 500. Okay, so that's the idea here, or that's the difference between 6.1 versus 6.2, is you need to change your standard deviation to become a standard error. And if you look at B, they ask you for the score, the mean score, or the sample mean score between 480 and 520. And again, this is what they ask you is basically based on this 65, how many of this 65 people will score between this based on our information, right? The sample mean, meaning based on just this 65 people. I took 65 people out. Based on this 65 people, how many of them, what is the probability of just this 65 people score between 480 and 520? And because we deal with this sample, that's why we need to use in our standard error, right? So normal CDF, my lower limit will be my 480, my upper limit will be 220. And again, my mean and my standard error, if you plug it in, this is what you have, roughly 0.6490, or roughly 65% of them, right? So 65% of the 65 people, right? So in that case, that's what we have. And again, your goal, and I cannot stress enough, right? Your goal, your objective, and your obstacle is when you read this wording, how do we know to use the regular standard deviation versus how do you know that you use the standard error, or you have to convert your standard deviation to this item? And again, the keyword is sample. If you see that they ask you for anything related to the sample, in this case, as you can see, they ask you for, in C, find the 80th percentile of the sample, right? If they left this thing out, if they ask you just say, find the 80th percentile of the data, right? If they just say, find the 80th percentile of the data, then you use the 118 as it is. But because they say that you find the 80th percentile of the sample mean, and because we basically find the 80th percentile of this 65 people, and because that they deal with a sample mean, we need to use our standard error, or this new standard deviation. Okay, so again, it's the same standard deviation. It's just that we need to alter it to fit the sample item that we have. Okay, we cannot just use the regular standard deviation because that is the population. Now we only need to compare the sample. So again, looking at this thing here, question with A, B, C, or question of what are the keyword that you need to looking for to know, or what is the keyword to trigger you guys to using this standard deviation versus the standard error, right? This item here versus this item here versus this item over here. Okay, so any question here with A, B, or C, ladies and gentlemen? So let's take a look at D. And in D, they ask you, would it be unusual if a sample mean were greater than 550? So remember, what is the unusual or usual? Remember, the cutoff for unusual is the probability is less than 0.05. Meaning in this word is basically they ask you is, what is the probability of a sample mean is greater than 550, right? So in order to us to find this probability, we need to find, again, this is 550 somewhere here, and we need to looking for the area under the needle curve greater than 550. And to find that item, we need to do the normal CDF. And again, my lower limit would be 550. The upper limit would be some humongous number. In this case, I put 10 million. And again, my mean and my outer standard deviation is this item. If I plug it in, this is what I have is 0.007. We would say, well, yes, it's unusual because the cutoff is 0.05 and this number is less than 0.05, is 0.007. So in this case, in order for you to identify if it's usual or unusual, you have to find the area or probability. And to do that, you have to do the normal CDF. So looking at this item here, that is what we need to do is you have the answer and then you say, well, if it's less than 0.05, we say that it's unusual. If it's more than 0.05, we say it's usual, okay? So the reason why I give you C, E, is this, ladies and gentlemen. If you look at E, they ask you, can you tell whether it would be unusual for the individual to get a score greater than 550? So does E have anything related to the sample that we have here? So the reason why I give you E is you can see, or hopefully you guys see, that there's nothing in E that mention about the sample, meaning we are not dealing with this 59 or 65 people. We have an individual, and we ask you is, if I go outside and or if I pick one of you guys, and I give you guys this test, is it unusual for you to score greater than 550? So because E does not mention anything about sample, we are dealing with the population item. And to do this thing here, same idea as before, which is we're looking at this item, but the only thing different is, right here, we are not dealing with this sample. We are not dealing with the 65 people as a sample. We deal with the whole population, right? I asked, if I take one of you guys, the individual, and give you guys this test, will you score greater than 500? Would it be unusual? Because we don't care about the sample that we took out. We only care about the population, and that is where 6.1 is. And that's why we're using the 118, because we are not dealing with the sample. And in this case, the result will be 0.3802. And you know that this thing here is not unusual because it's bigger than 0.05. Okay, and that's the reason why I want to throw in E, to show you that if you don't see any sample, if you don't see any word in terms of the word sample, then we are dealing with the population. If you see anything that relates to the sample item, then you're using the sample, and that's why you're using this standard error. Everybody see the difference between when to use the sample item, which is the standard error, versus when you use the population, which is 6.1. All right. If you don't have question, we have one more problem, but let's stop here for today. I think I'm running out of time.